Okay, so do we want to skip that one?
Yeah.
Okay, we can skip that one. We can skip that one, right?
Yeah.
Okay, let's do this one just for a little bit of practice. What are our options on this one? I mean, I want to do this review too, because we want to hit this stuff one last time, so we're really stick. What's one way to factor this? Bottoms up. Okay, so let's go through bottoms up. So with bottoms up, remember we're gonna find out. We got to find factors of AC that add to B, right? So AC equals 168. And B equals positive 34. So what are we going to get there? I don't know, 20, probably like, what is it? Yeah, I'm going to say, second would be 2, what, everybody know what it is? What do we got here? We know what they are yet? let's make a factor tree.
28.6.
Is this 28.6? I was thinking it was something like that. Okay. All right, so we got 28.6. So remember what we do. We're just gonna, with bottoms up, what's the next step? Well, first we gotta write out, we gotta split it like we normally would when we're factoring a quadratic where A is 1. Remember, we just set up the template, and then we've got our magic numbers, just like normal, but then what? Right. So we find magic numbers. I mean, just like we would on a problem like this, right? I mean, if we did magic numbers, we would just go, I wouldn't do this quick, but what would they be, like -5, +1, done, right? But for bottoms up, we're not done. What do we have to do? Yeah, we got to divide by A, which is 8 in this case, reduce the fractions, and then go bottoms up if necessary. If they don't become integers, you go bottoms up. Neither of these do. So what do we get? 28/8 reduces to 7/2. Is that right? And then here we get 3/4. Last step. Bottoms up. Yeah.
Oh yeah, have you ever tried to drive a car without headlights at night with a bunch of cops around?
No, I haven't. And I don't recommend it.
I did last night at 10 o'clock.
Oh, how'd that work out for you?
I made it home.
Good. Okay, so that makes sense? All right, now here's the other thing I want to say about this. Remember, this is good. This is kind of a good way to finish out the year. Doing something that's, you guys are a ways away from college, but to kind of get you ready for the idea of college, right? So this is one where you're going to have a little different approach to what I mean by that. What I mean by that is you only get one retake at most on this, right? So you've got to take your time and check everything. Everything you do, you should know for 100% certainty you got it right before you turn it in. How would you check this one? Multiply it out, and definitely do that, right? Multiply it out, okay? Okay. The other thing you could do to do a quick check on that, multiplying it out is the best way. What else could you do? Being as you're just changing the form of something, you're not solving an equation. You could plug in a random value, evaluate the function before, evaluate the factored function afterwards, and see if they're the same, right? But multiplying it out would be just about as quick and probably better. Okay, what about this? That's easy, right?
Yeah.
What is that one? Good. Okay, that's difference of squares. Good. X squared minus 11 squared. X minus, about 11. X minus 11 and X plus 11, either order, doesn't matter. Okay, good. Can we skip that? I mean, what would we do there? Well, no, what do they want us to solve the equation? Well, they already did the hard stuff.
Yeah, you just solve for x each time, it's 6/7 and 9/4.
Good. Right, so we're just gonna set each, I'll just do one of them. Set each equal to 0 and solve, right? Okay, plug them in to see if they work. That's pretty easy to do. You have to get the zeros of the factors, right? Okay, is this making you feel a little better about things?
Maybe.
Okay, yeah.
Is it gonna be exactly like this?
Yeah.
You go.
Okay, so no big deal. Factor it. Set the factors equal to 0, right? Let's do one of these. What does this factor into? What are the magic numbers? So what? Minus 8, minus 10, right? And so what are our solutions?
8 and 10.
Okay. Okay, what do we do with this? So you could either solve this by factoring, or because remember this is a case where now I didn't change the wording on anything on here. I'll probably do that before I do this next year. But so I left all this wording that says if it's imaginary, blah blah blah. But really, what the wording should say is find all real solutions. There's no I's or anything on the test. It's not like it's okay. So you just know that. No imaginary numbers. So I could factor this out, or because it's one where we can point to a single value of x, we can isolate it if we're just looking for real solutions, right? So then we just get x squared equals 9. So what does x equal? Plus 4 minus 3. Got to enter them separately, as you well know.
Wait, this is right.
Yeah.
You're saying that on the final, we're not gonna have to do anything with imaginary numbers?
No. I was going to add a bunch of harder questions
Is there
on this,
gonna be
but
graphing?
I ran out of time.
I love you, wife.
Is there gonna be graphing?
Not
Not
doing
doing
anything
anything.
with imaginary numbers.
Okay, so what about this guy?
0 and 7.
Yeah, I mean, these are ones, you all know how to do this, but like in my regular Algebra 2 classes, for some reason, those are harder for people to do than if you're factoring a trinomial. What do you always try to do anytime you're factoring anything, though?
What does that mean?
This is sign language for what? Yeah, you want to factor out a greatest common factor, right? So we'll split that up into x times x plus 7, which gives us 0. Any monomial factor, right, that's only got one term, when I set it equal to 0, it's got a variable in it, that is, right? When I set it equal to 0, I just get 0, right? Okay, 0, negative 7. That's it. Right? Okay, questions on that one?
Is it just gonna be these kinds of problems the whole time?
No. It's broken into 7 different categories, 4 questions from each category.
7 different tests, 4 questions on each test.
One test.
Okay, so what about this
There'll
one?
be questions like how much money does Jill spend on makeup?
Hey, what do we do? Just isolate, right? So we're trying to solve this thing. I'll divide both sides by -2. So x squared equals 81. So what's x? Okay. What's the value of c that makes the expression a perfect square trinomial?
196.
No? Oh yeah, you're right. 196. Good. So it's going to be half of b squared, right? Remember this for completing the square? But that's all they ask you to do, is just know what the number would be that you add to complete the square. Okay, so negative 14 squared, 196. Okay. Hey, but there are some at the end you're going to probably want to go through. So let's get to those.
I wanna go through all of them.
Okay, what about this? Solve the equation. Wants you to find exact simplified solutions. Once again, I mean, there's no, normally, like next year it'll say find the real solutions. So what about this then? How are we gonna solve this one? Quadratic formula. Oh, and by the way, on the one, I'm gonna skip back for just a second. Well, actually, I'll do it on this one. Never mind, we'll do it on here. So quadratic formula, right? It's a quadratic equation in standard form. So what are the values of A, B, and C? A is 8, B is
38.
C is
45.
Okay, y'all know the song. So x equals negative B.
Plus or minus square root b squared minus 4ac divided by 2a.
There you go. Okay. So I think you can't. Oh, by the way, you cannot use graphing calculators on this. I think Kim said you can use a regular, like non-graphing one, but I'll have to verify that. I'm not even sure about that. But we probably don't need to. We could. Well, for now, let's. Somebody just crank through that because those are big numbers.
38 squared.
That's a big one.
Squared is 1444.
Okay.
Why so you say that?
1444.
38 squared is 1 4.
Minus 32 times 45. What's that?
A large number.
Yeah.
1440.
Okay.
4.
So that's negative 38 plus or minus. What's that going to be in there?
2.
4.
Yeah.
Or 2.
Ha! Told you.
67 by that.
So we end up with two answers. If we take the plus sign, we get x equals negative 36 over 16, which we could reduce to, what's that going to be? 9/4. Negative 9/4. If we take the minus sign, x equals negative 40 over 16, which is negative 10/4.
No, by the way.
5, say it again?
5 halves.
5 halves. Oh, 10/4, 5 halves, duh. It's good having you around.
Oh my gosh.
So,
Wait, hold on,
Oh.
hold on.
do we have to have that memorized, or?
The quadratic formula?
Yeah.
Yes, you do. Yeah.
Wait, we were taking this test.
You get a choice. I mean, it's just sometime before the end of the year. I don't care
where?
when. Say it again.
Where?
Either here or in a lab.
The end of the school year, the end of the Chinese New Year, or the end of this like annual
The
year?
end of the Aztec year. of
Or
course.
the end of the world.
So I'll be gone tomorrow. It'll be available tomorrow. If you want to do it tomorrow, you can. You don't have to. Okay.
No, tomorrow's a freebie. What? Mr. Boy, is tomorrow a freebie?
I don't know if I'm gonna do it for you or not.
I'll do your makeup sometime.
Sorry. Okay, here we go.
Five and 2.
Okay, so what about this one? Are there magic numbers that multiply to 7 and add to 10?
Oh,
X plus
no.
5 times x plus 2.
Say it again.
X plus 5 times x plus 2.
No, they don't multiply to 7 and add to 10.
Factors of 7.
You done did it
Okay, let me get,
backwards.
listen, you're gonna wanna finish this, I promise you, so let's get through this. There's some stuff at the end that I want you to review, because I think you might need to. Alright, so, this is one where, what would we do, being as there are no magic numbers? Quadratic formula. So x would just equal negative b plus or minus the square root of b squared minus 4 times 1 times 7, 28 over 2. Okay, so what do we get? That's square root of 72, right? Okay, so then we gotta just reduce that radical, right? Or what's the biggest perfect square factor of 72? We can do better than that.
Oh, it doesn't even
It does.
Probably 4.
36.
36, there we go. So we get negative 10 plus or minus the square root of 36, which is 6, times the square root of 2, all over 2. Remember that it's better in these cases to just, it's been a while since we've done a lot of these, but remember we always split the fraction because then you want to reduce as much as you can. And sometimes one fraction will reduce and the other won't. In this case, they both do. But it's still a better idea just to split this up. So we get negative 10 over 2 is negative 5. What's this reduced to? So the 6 over 2 reduces to a 3 times the square root of 2. Okay? Good?
Yes.
Okay. Okay, simplify. This ought to be pretty fresh in your mind. What do we do here? Yeah, it's got a factor, top and bottom. Top's already factored. And then to simplify a rational expression, we're just going to cancel like factors, right? So what's the bottom factor into?
7, 6, and 7.
And I don't need parentheses on it, do I, at the bottom? It's only one factor. There it is, right? Okay. Find the product.
See, that's gonna be rough.
We just did this stuff.
Yeah, I mean, this ought to be really fresh in your mind. This is no big deal. We've done a million of these problems. This is just, and there's gonna be some variability in these. I mean, but you're good at it. It's not a problem. So we got plus 6, x minus 5. Okay, so what do we get?
-5 cancels out.
Those cancel.
Those
Good.
X plus 4, x squared plus x.
11x.
11x.
It says in Q of that.
Okay, so okay.
That's it?
Yeah.
Girl, what?
Okay, what about this one? This is honestly, these are the hardest. Would you not agree? These are the hardest questions in Unit 5. You think? Yeah. I mean, this isn't a horribly complicated one, but because you have to get these are the hardest ones in Unit 5, I think. What about? So what are we gonna do here? What's the first thing we gotta do? You tell me.
Distribute the
Find a
eight.
common denominator.
Okay, we gotta find a common denominator first of all. Good. So let's factor everything. So we get 8 over x minus 9, and that's always our first step, isn't it? When we're dealing with simplifying or doing any arithmetic with rational functions, you always have to factor everything. And mainly because we gotta know, well, not mainly, but for several reasons. One reason being that we wanna be able to see what cancels, know what our common denominator is, but also we gotta know what are the excluded values, right? So, just factor out an x. So now, what's our LCD gonna be?
X squared plus x.
Okay, so it's just gonna, if we write it in factored form, we want the smallest product of factors that includes an x and includes x times x plus 1, right? Which is just x times x plus 1. Agreed?
Yep.
Okay. So then we just need to get that common denominator. So what do I have to multiply the first denominator by, and therefore the first numerator also? Right? And then we end up with right? Got a common denominator, so in this case we combine the numerators, subtract the numerators. And what do we end up with then? 8x minus 1, good. Nothing cancels, we gotta check and see, nothing cancels, right? I can't factor the top and cancel anything, and so we just end up then with 8x minus 1 over x squared plus x. Okay. And it doesn't say you have to expand out the denominators on this. I mean, really, honestly, it's probably better in most cases not to. When we get to calculus, we'll always want everything factored. All right, so questions on that? That's good. We've been doing a ton of that.
I like that one. I'm with you.
Okay, how about this? The only thing, this looks a little different just because the functions are stacked instead of being using a division sign, right? So I could rewrite this if I wanted to as 1 minus 4 over x divided by if I wanted to, right? What do I have to do to these? Because there's a general strategy with this, right? When we want to divide rational functions, we have to write the top and the bottom as complete big fractions and then flip and multiply. Right? So we've got to simplify the top and the bottom. Now I want to remind you real quick how that relates to order of operations. It's not a very hard problem, but I want you to kind of see the bigger picture on this. When we're simplifying, we go top down, right? Well, how would we know that we're going to simplify the whole top and the whole bottom first? Because the first thing we run into are parentheses. You got to remember in math, you got to remember implied parentheses. There are always implied parentheses around any function, but also around the numerator and the denominator of any fraction, right? So I actually put them in here, but they weren't written originally. We have these parentheses though, right? So inside the parentheses, we've got to simplify all this stuff. So what do we do to the top one? If I want to combine those two numbers, what do I do when I subtract fractions? What do I have to get? Common denominator. So this is just 1 over 1 to start with, so what do I have to multiply top and bottom by in that fraction? Yeah, so that's just going to be x over x, right? In the bottom, what do I need to multiply by? 5. Right? And so we end up with, on the top, x minus 4 over my common denominator of x, agreed? Divided by, on the bottom, 5x plus 1 over my common denominator of 5. And now what do? Flip and multiply. Okay, so we end up with x minus 4 over x times 5 over 5x plus 1. Okay, and so I just multiply those out. And what do I get if I do? 5x minus 20 over 5x squared plus x. Okay, once again, how would I check this one? Plug in a value, because it's not an equation, we're just changing the form of something. Good. Okay. How about this? Find all valid solutions. So this is section 9.3, right? Our very last section. Okay. So what do we do with this? Okay, right. So we've got to figure out what we're going to clear fractions. That's all we're doing. Right, we're going to multiply both sides through by the LCD. What is the LCD? That's not very good. So x squared, right? Good. So the smallest thing that 1 and x squared all divide evenly into is x squared, right? So we'll multiply an x squared through. Okay, and what happens when we do that? Remember what we did earlier. Whenever we're clearing fractions, we know the things are always going to reduce, so we always reduce first and then distribute. Well, this is pretty simple. We just get x squared. X squared over x is x times the numerator, which is 12x. Over here, the x squareds cancel, right? So I just get a negative 32. Now what? Yeah, scoot 32 over. Set equal to 0, standard form. And then then you have quadratic equation in standard form. Take your pick, solve it, okay? We'll just move on. You guys can do that. Solve the proportion. Well, that actually isn't a proportion. Okay, change the wording on that, but same kind of thing, right? What are we going to do there? Yeah, so we just multiply top and bottom by 2x.
Yeah.
Right? Okay. Or multiply both sides through by 2x.
Why don't you just simplify the 6 over 2?
Yeah, you could, couldn't you?
Over x.
Yeah, okay. Good idea. And so if we multiply 3 by x to clear the fractions, what do we get? 5x equals, or sorry, 5 equals.
Why?
If I multiply by x, right? Because that's my common denominator. X is canceled.
Oh, 3 plus x.
3 plus x, so what's x?
Sure.
Plug it in, see if it works. Is 5 halves equal to, let's see, that's gonna be 6/4, so that's 2/3 plus 1. Hang on, no. What was it again? 5
You should plug it
halves.
back in.
Did that work? Equals 1/2, sorry. No, that's not right.
It's 3/2.
3/2, yeah, there we go. Gosh, I am not thinking today. Check, right, that works. Okay, so we got it. Okay, solve the proportion here. Same kind of thing, but here's the thing I wanted to show you on this. I think that last one, I shouldn't have said proportion. When you're solving, why is this a proportion? Why do you call this proportion instead of, I mean, it's a rational equation, it is. But it's a proportion because there's just one fraction equal to another fraction, right? There's no other terms in there. What's our trick? I mean, think about this in terms of, you know what to do with this. You would have had a strategy back in Algebra 1. What would you do? Cross multiply, right? Okay, why does that work? Because you're effectively doing the same thing, aren't you? When you cross multiply, you're multiplying both the top and the bottom by the least common denominator, but just canceling one of the factors. Do you see that? Right, if I multiplied, the least common denominator would be x plus 6 times x minus 12. If I distribute that through on the left, the x plus 6 would cancel top and bottom, leaving me with an x minus 12 to multiply, right? On the right side, the x minus 12 factors would cancel top and bottom, leaving me to multiply x plus 6. So cross multiplying is really just a shortcut for what we're now doing, right? Okay? So, should we skip it?
No, I think we should do it.
Sure. So if we cross multiply, we get 2 times x minus 12 equals 6 times x plus 6. 2x minus 24 equals 6x plus 36. What do we get? 4x on this side. What do we get here? Negative, is that 60? So if I divide by 4, x equals negative 15. Okay, and we can check it out. Does it work? That gives us 2/9 equals 6 over, what? Is that right? Oh, that's, I guess it works. So negative 2/9, right? On this side, we're going to get 6 over 27, negative 6/27, which is 2/9. Okay, so it checks. How did I get this? I just plugged in negative 15.
Wait, what?
Yeah.
Oh, well, look at it.
Yeah, I just plugged it in on both sides just to check it. Okay? Okay, probably, I mean, this one's got all the instructions too. I want to give you at least one on there where you got to do. I couldn't resist adding this part. I want you to put in. I want you to know how to find the restricted values too, right? So we end up with, what are we gonna do?
Factor the x squared thing.
Okay, right, we gotta write everything in factored form. All of the rational expressions need to be written in factored form, so, oops. We'll leave a space for that. We get x minus 1 over x minus 5 equals negative 7 over x minus 6 minus 4 over, what's that factor into?
X minus 5, x minus 6.
Okay, and so what's our least common denominator then?
X minus 5, x
Good, we'll just multiply both sides through by that, right? Or actually, yeah, because we're solving an equation. So if we do that, what are we gonna get? Can you tell me if I multiply, I'll write it out.
4, 9.
Okay, so if we distribute that through, on the left side, the x minus 5s will cancel, right? And so we just end up with x minus 6 times x minus 1. Everybody agree? Okay. On this side, in other words, we can see this is going to happen, right? And so we just get that, right? On the other side, so I'll just try to color code this here. So we got, when I distribute to that term, the x minus 6's cancel, right? And I'm going to get negative 7 times x minus 5. When I distribute to that term, the x minus 5's cancel. Oh, okay. Right, and then I end up with just a plain old x minus 6 times 4.
No.
Oh, yeah, I'm sorry, they all cancel, don't they? Whoops, what am I doing? Okay, those all cancel. So I just end up with minus 4. Right? Am I good?
No, wait.
Okay, and remember, what you can do, the mental shortcut you can take here is you can just think about this, being as I know I've got a least common denominator that is guaranteed to be a multiple of each of those factors. You can just, when I distribute, I can just think to myself, okay, so that's canceling, what's left over to distribute to the top, right? Okay. And then we just solve it, right? So we'll expand this out. What's that going to give us? X squared minus 7x plus 6 equals negative 7x plus 35 minus 4. If I put that in standard form, let's see, that the x's cancel, don't they? Add 7x to both sides. And I'm gonna get what? 31, so minus 25. So what are my solutions? Okay, but we gotta go back up now, and we gotta say, what are our restricted values gonna be? Well, look at what's the least common denominator? 6, right? Those are the factors of the denominators, and so we have to exclude values 6 and 5, and our solution includes plus or minus 5. So, can I include the negative, or can I include the 5? No.
It's extraneous.
Right? Can't include the 5 because it's an excluded value, so that's not a valid solution, right? That's an extraneous solution. So I can't put that in Moodle. The only one I can put in Moodle is that one, right? That one's gone, just the minus 5.
Wait, what was that other number?
5,
Why can't we put that in there?
because it's excluded, right? It's our domain is x cannot equal 5, x cannot equal 6. So 5 can't be an answer. Yeah.
When you find those common denominators, is it basically just the ones that are either subtracted or added to x?
It's, well, okay, yeah, but what it is, remember, all the common denominator it's the least common multiple of all of the denominators. So it's the smallest product of factors.
Oh, because 5 and 6 can be added, like, 5 and 6 can be added to 11 and
Right, so I just factored that is all I did. Yeah, we just wrote this in factored form.
Is it always going to be like that?
No, I mean, not always. If it weren't, okay, if it weren't, what if you had something like this? What if you had, it makes the question harder though. I mean, on a 28 question final, you're not gonna get anything probably harder than that. But we've done some in the past where maybe these didn't factor into the same things as these. What if this was x minus 4 and x plus 7 or something? Well, then I would have more excluded values and my common denominator would just be a lot bigger, wouldn't it? It would have to include 4 factors instead of 2. And when I multiplied it out, I'd get this enormous, big polynomial equation on the top to solve instead, which may or may, that's makes it much, much more arduous to do the problem.
Alright, so if it does go in there, does the x squared minus 11x plus 3, does it just kind of disappear? You like just erase it? With that, well, like, in theory, you would just kind of replace it.
What do you mean by that?
Because now there's that x minus 5 times the x.
Okay, so it's the same thing, but we want to write it in factored form because when it's in factored form, it's much, much easier for us to cancel stuff.
But like, it does kind of replace it.
Oh yeah, it does. They're equivalent expressions. I mean, it's saying this is exactly equal to x minus 5 times x minus 6, but that's just in a better form. When it's in factored form, we can see that, okay, in reality, we've got these shared factors on the bottom, and so we don't have to have as big a common denominator. It'd be like doing this. It'd be like if we were doing something like 5/8 plus 5/6. I don't have to have 48 as my common denominator because they've got some shared prime factors, right? This is 2 cubed and this is 2 times 3. And so all I'd have to do is just 2 cubed times, see what I'm saying?
Yeah.
Times 3. Not instead of 6 times 8, right? So I could make this a 24 instead of a 48. Same thing's going on up here. If we factor it, we don't have to multiply x minus 5 times x minus 6 times x minus 5 times x minus 6 because these are shared factors. Okay, does that make sense?
Yeah.
Okay.
And so you do that instead of simplifying.
Well, so what we do then, remember, when we solve an equation like this, put this in perspective. We're just clearing fractions to make the equation easier to do, right? Because then it makes it a non-fractional equation. It's exactly identical to if we did something like this. I want to make sure this is good. I'm glad we're having this discussion. So what if I gave you a problem like this? X over, say, 3x over 4 minus 5x over 6 equals 1/12. What would you do to solve that? First thing you would definitely do. Okay, least common denominator is? No, 12. I'd multiply both sides through by 12, right? That's the smallest number 4 and 6 and 12 all divide into, right? So if I multiply by 12, what happens? Right, so 12 over 4 is 3, oops, what's bad, 3, anyway, 3 times 3x is 9x, 12 over 6 is 2, times 5x is 10x, right? So I just get that. Now that's an easy equation to solve, right? Same strategy here. When I clear the fractions, right, when I multiply both sides through by the least common denominator, I end up getting a really easy equation to solve, but the danger here is, here's the difference. We started off with x's with factors involving x's in the denominator, right? And when we multiply both sides through by the least common denominator, we lose all of those denominators, right? This equation right here looks like there's no restriction on the domain. Let's just solve it, right? I mean, it's just a regular polynomial, quadratic polynomial. There's no reason to exclude any x's. So that's why we've got to, before we do that, remember, we've got to go up here and say, okay, what are all of the values of x that would give us a 0 denominator and exclude those? Because you won't see y later on. If I gave you this problem to start with, the domain would be all reals, wouldn't it? See what I'm saying? Okay. All right. What about that? Okay, we're going to write that as a simplified radical. All we got to do, remember, this is the kind of thing, it's been a while since we did these, but we want to write this in the form what's outside the radical and what's stuck in the radical, right? We always break, all we do with these, the hardest part is the number part. I mean, the number part. And that's not very hard. How do you simplify the square root of 20? Yeah, square root of 4 times square root of 5, right? What's the square root of 4, Emma? Good. So there's the number part, right? Okay, so what about the square root of x to the 5th? Well, the easiest way to deal with that, in my opinion, is to write that, think of it in terms of rational exponents, fractional exponents. So the square root of x to the 5th is x to what fractional power? 5 over 2, because we have a 2 there, don't we? Right? On a square root. And remember our trick? All we have to do then is if we think about that exponent as a mixed number, the integer part is the power that is outside the function. And the fractional part represents what's stuck inside the fraction, right? So what is 5/2 as a mixed number? X to the what? 2 and 1/2, right? So that just gives us an x squared outside, and it gives us an x to the 1/2 inside, right? Done. Okay. Does that make sense? Okay. That to me, I like that trick. We did a lot of much harder problems than this with other indices than just 2, but all you gotta do is a square root on this one. Okay, how about this?
How did the other one
So in the answer, in Moodle, we would just write this literally as 2x squared times the square root of 5x. Okay? Okay? Tell you what, we'll, out of time, Friday, there's a few more to go through. I think we have just like 4 or 5 more. Hit those on Friday. You can test tomorrow if you want to. Otherwise, Friday.